Okay, I'm going to use this short video to go through how to solve a restriction enzyme gel electrophoresis problem similar to the ones that we have on the biotechnology practice problems worksheets that I've posted online for you guys to work through. I actually am going to use the first question to do this. So if you look at this question, what you have is a restriction enzyme map. You have a plasmid, and you have these lines that represent the restriction enzyme cut sites. So this would be where echo R1 would cut. This would also be where echo R1 would cut. And it gives you the number of base pairs. And they also give you the cut sites of small one. So these are two restriction enzymes that are cutting this plasmid. Note that the entire plasmid is 2,800 base pairs. That's what's given here, right? The entire circle, that is the plasmid, is 2,800 base pairs. So what you need to do in this question is to fill in the chart and then prepare a gel that shows where the fragments would be using gel electrophoresis. So the first step is figure out the size of the fragments that would be produced if echo R1 is the only restriction enzyme cutting. So it would cut here, it would cut here, and it would cut here. So this one is fairly straightforward. It cuts at the 0 site and also the 700 site. So if I go to the answers to help explain, it's cutting here and here. So one of the bands is going to be 700. There's also a cut here. So 1790 minus the 700 is how you get the 1090. Then to figure out the final fragment length, because there would be 3, it's the 2800 minus the 1790 to give you the 1010, right? So we're cutting here, here, here. So it makes sense. So we get 3 fragments. This fragment, and then this fragment. We are cutting the circle in 3 spots, so you get 3 fragments. Same idea with small one. Okay, so now we have a cut here and a cut here. So if we subtract this 550 from the 1680, that's how we get the 1130. Right? Now notice it's only cutting in 2 spots, so you're only getting 2 total fragments. So we have this fragment, which we just calculated to be the 1130. We need to subtract that 1130 from the total size of the circle of the plasmid, 2800, and you get the 1670. Then the final one should be straightforward. You get a cut here, cut here, cut here, cut here, cut here, because now you're filling in what the fragments you would get if both restriction enzymes were doing the cut. Okay, so you just figure out these sizes from the map. And now you have all these different size fragments. The next job is to sketch the gel for all 3 scenarios above. Now, you have the list of the fragments in your chart. It's now a matter of plotting those fragments in the gel. Create a rectangle. Don't put columns, just one big rectangle, and put the name of the restriction enzymes across the top. Make sure you have a negative listed here and a positive here, because the fragments are going to travel towards the positive because they're negatively charged and they're attracted here. The smaller ones are going to travel the furthest. So as long as you place them in the approximate right spot, it's not like I'm going to get a ruler out and measure exactly where they are, but as long as you got, similar size fragments in the same position, like this 1010 and this 1010, and you have the bigger fragments near the top and the smaller fragments on the bottom, then you'll get the full marks for this. Okay, so that is how to do one of these restriction enzyme problems. Now note with this next question, number 2, I'm not going to do it for you, but because it's linear, the number of fragments that you create is going to be a little bit different. So if you have a linear structure here, you have Hind 3 cutting here and Hind 3 cutting here. With a linear structure, only 2 cuts will produce 3 fragments. You got this fragment, you got that fragment, and then you got that fragment. Okay, so that's the difference between a question that has a circle, like a plasmid, and a question that has a linear piece of DNA. So keep that in mind if you encounter any questions like this on any assessments.